in vertex form, specifically applications of quadratic functions. A few days ago, when we were working on applications of quadratic functions, we introduced a spaceship. And that gave us a 3-2-1 blast-off strategy for solving application problems. And the first step is always to read your question, then read it and highlight your key information, and then read and underline what you're looking for and the units that are involved. The next step is to choose an appropriate tool, skill, model, strategy to solve your problem. Once you've done all that, you've got a good idea of what you're looking for and what you need to do, and applying what you know, including all of your steps, becomes much easier. At the very end, you're going to reflect on your solution. Does it make sense for the situation I have? So I'm going to start with this problem. It says the graph of the parent function of a quadratic is vertically expanded and then translated 5 units to the left and 20 units down. If the y-intercept is 30, determine the equation of the resulting function. I've read it. I'm going to start again. But now I've got my trusty highlighter in my hand, and I'm going to do it again. The graph of the parent function of a quadratic is vertically expanded. That's important. Translated 5 units left, 20 units down. Y-intercept, oh, that's all important, is 30. Determine the equation of the resulting function. Go back again. The graph of the parent function of a quadratic is vertically expanded, translated 5 units left, 20 units down. Have I got all the key information? Yeah, I pretty much covered it all, I thought. But it hasn't told me what to solve for yet, so I'm going to keep reading. If the y-intercept is 30, determine. Oh, that's a very important word. What am I determining? The equation of the resulting function. And of course, I'm finding an equation, so there are no units involved in this. Now, the first thing I have to ask myself is, I know how to write the equation of a quadratic function in 2 forms. One is vertex form. The other is standard form. And we're working with transformations, so the easiest approach would be vertex form. We know it's vertically expanded, and it tells me a is greater than 1, or that should say less than -1. Sorry for the typo. Okay. So I know my a has to be 1.5, 2, 10, or -3, -50, something like that. It can't be between -1 and 1. Okay. I did not want you to see all of that. So let's go back so you can't. It tells me it's translated 5 units to the left. Well, that tells me right there, and I can write it here, h is 5. And it needs to have a negative because it's going left. And it's 20 units down, which tells me the k value is -20 because I'm going down. So once I do that, I can plug those values into this equation. Now, the thing to keep in mind is this says x minus h, so it'll be x minus -5. Okay. So when I plug it in, it's x minus -5 squared minus 20, and I simplify that negative to be a positive. The last thing we know is the y-intercept is 30, so it gives us the point 0, 30, and we can substitute the 30 in for f at x, and 0 in for x into the equation that we have right here. So the 0 is going in right there, and the 30 is going to go in right here. And once I do that, I can simplify. Don't forget I have to do BEDMAS when I do this. So 5 squared is going to give me 25, and I need to divide both sides by 25 in order to solve for a, which is 2. And the equation becomes f at x is 2 times x plus 5 squared minus 20. Does it make sense? This shows me a translation left 5. That shows me a translation down 20. And this shows me a vertical expansion because the a value was positive. And if I substitute x equals 0 in, I will end up with 30 back out, so I know my solution is correct. Next, we're going to look at the equation of a quadratic function that's congruent to f at x is 2x squared, has a vertex at 4, 2, and has no x-intercepts. I'm going to pick up my trusty highlighter again, and I'm going to read it and highlight important information. Determine the equation of a quadratic function. Absolutely, that's important. I need to know I'm not doing a straight line or another function, which we would learn possibly later in 11U if you go there, or we will definitely learn other functions later in the semester. So we're looking at the equation of a quadratic function that's congruent. Oh, I think I've heard that word before. To the function f at x is 2x squared, has a vertex. Vertex is very important at 4, 2. No x-intercepts. I'm going to read again. Determine the equation. Oh, right there it's telling me what to do. I want the equation. Let's make sure that's it. Of a quadratic function that's congruent to the function f at x equals 2x squared, has a vertex at 4, 2, and has no x-intercepts. We really have to think, what am I looking for? An equation. It gave me the vertex, so vertex form would be the most sensible choice to start with. My vertex is 4, 2, so that's my h value, and that's my k value. So I'm going to start out by substituting in positive 4, so it's going to become a negative 4 in the equation overall, and positive 2 for k. The next thing I have to look at here is it's congruent to f at x equals 2x squared. So what that tells me is a is positive 2, or a is negative 2. Right? That's what this piece of information is telling me. The big question I have to ask myself is, how do I figure that out? If a is positive 2, my function's opening up. If a is negative 2, my function opens down. Let's take a look at what the graph looks like. Quick sketch here. Not even going to bother numbering it. The vertex is here at 4, 2. If it opens up, it's never crossing the x-axis. If it opens down, oh, wait a minute. I'm going to cross my x-axis. Not a very good graph to scale, but I wanted them to be different colors, so it's not very great. Sorry, guys, not very good. Anyway, so now the only way that the graph cannot have x-intercepts as the vertex is in this first quadrant is if a is in fact positive. So the equation, we can just substitute the 2 in, and we're good to go. And before class tomorrow, you should be able to finish exercise 9, page 17, number 1 to 3.